Hello and welcome, and in this video we will be graphing linear inequalities. Okay, now if you haven't watched the video on graphing linear equations, make sure you check that out first. I'll put a link in the description below because graphing linear inequalities actually takes a lot from graphing linear equations. There's really not too much of a difference. There's really only two differences with graphing linear inequalities. The first of which is that we're going to have to shade part of the graph, similar to when we kind of plotted our solutions on a number line with absolute value inequalities. Remember, we had to either shade inside or shade on the outside. We're going to have to shade part of the actual graph when we graph linear inequalities. And the other thing we got to think about is whether or not we're going to be using a solid or dashed line when graphing these linear inequalities. So let's go ahead and take a look at a couple of examples. Okay, so we have an example here. Okay, we have y greater than or equal to 2x minus 3. Now, to start this, we graph this the exact same way we do a line. We get it in slope-intercept form. Once it is like it is here, we just use the slope and the y-intercept. So the slope in this particular problem is 2. You can also think about that as 2 over 1, remember, which means that we're going to be going up 2 and right 1, okay? And the y-intercept is negative 3, so that point, remember, is 0, negative 3. So we plot our y-intercept, and now we go ahead and we use a slope, up 2 over 1, up 2 over 1, up 2 over 1, and we just kind of keep doing this. Oops, that one wasn't right. Let me get rid of that. Up 2 over 1, up 2 over 1, up 2 over 1. And now we can go backwards, down to left 1, down to left 1, down to left 1. So we plot all the points the exact same way, but this is where those two differences come in. We got to think about if it's going to be a solid or dashed line. Now with the equations, it was equal to, that's why we used a solid line. So if it's an or equal to inequality, we're still going to use a solid line. Like in this case, since it's or equal to, we still are going to connect these with a solid line, okay? Now, if it wasn't or equal to, if it was strictly greater than, then we would actually just connect these with a dashed line, okay? So that's the first difference. Now, from there, we got to think about where we're going to shade this particular graph. Now, there's a couple of ways of doing this. The way I like to do it is I just think about, okay, is it y greater than or less than? If it's greater than, we shade above the line, and if it's less than, we shade below the line. Okay, so since this is greater than, we're going to shade above the line, which is in this general region here. So we would shade all of this region. Now, if that's a little difficult, because I know some people actually struggle visually seeing what is above and what is below. In that case, what we can do is we can just plug in any point that's not on the actual line, plug it in right into the inequality and see if it works or not. So for example, 0, 0 is not on the line, so I'm just going to plug in the point 0, 0. So 0 for y and 0 for x. And if this is true, then I'm going to shade where the point 0, 0 is, which is in this region right here. So it should end up working out. So if I did this, I would get 0 is greater than 2 times 0, which is 0 minus 3. And I get 0 is less than negative, or excuse me, 0 is greater than negative 3, which is true, which means we would be shading in the region where 0, 0 is, which once again is above the line. So this is where we would shade, okay? And you might be asking, why are we shading at all? That's because that's where all the solutions to this inequality are. All the solutions to this inequality are going to be in the shaded region, and that's the case for every linear inequality that you graph. All the solutions are in the shaded region, and if it's a solid line, also on that line as well. If it was a dashed line, it would only be the points in the shaded region, okay? So this is greater than or equal to. Since it's greater than, we shade above the line, not below the line, okay? Let's take a look at a problem where you actually end up having to shade below the line, which is going to be a less than problem. Okay, so we have a new example here. We have y is less than negative 1/4 x plus 5. So once again, we're going to start this as if we were just graphing a normal line. So we're going to be using the slope, which in this case is negative 1/4, which means we will be going down 1 and right 4, okay? And the y-intercept is 5, which is the 0.05. So once again, we're going to start this the exact same way. I'm plotting my y-intercept, and I'm now using this slope of -1/4. So I'm going down 1, right 4, down 1, right 4, okay? And now I'm going up 1, left 4 to go backwards just to get some kind of more points over here, okay? And now, this is where it starts to differ from an actual linear equation, because now I gotta think, well, am I gonna connect these points with a solid or dashed line? Now, since this is not or equal to, we're going to be using a dashed line. So I'm just gonna connect these with a dashed line, the best that you can. Mine's not gonna be perfect. That looks good enough to me. So a dashed line because it was not or equal to. And now we got to think about where the shading is going to be, okay? So once again, you can think about this as if it's greater than or less than, we shade above or below. Now, since this is less than, I'm going to be shading below, okay? Now, once again, this one it might be easier to see if it's above or below, but if not, you can test a point that's not on the line. So say, for example, I wanted to test, let's say I wanted to test this point right here, 0.8. Now, if 0.8 works, I would shade in this region here where 0.8 is. If not, I'm shading in the other region. So this one is not going to work, just so you know. So I'm going to plug in 0.8 into our inequality. 8 is less than -1/4 x. Well, x at that point is 0 plus 5. Well, if I do this, I'm going to get 8 is less than 0 plus 5, and 8 is not less than 0. That is false. So since that doesn't work, I would shade in the other region, which is why it's in this region here. And once again, all the points in this region are solutions, okay? So I can grab any point from that region, plug it into the inequality, and it's going to work. So once again, that's why we graph. Remember, in graphing linear equations, I say the reason we graph is to get a visual representation of all the solutions, because you can spend your entire life until you die and still not make a dent in writing all the solutions out by hand. A graph is a very nice and easy way of doing that. Okay, so that's graphing linear inequalities. I'll go ahead and do one more example. Now, both of these were in slope-intercept form already. Let's take a look at one that's not in slope-intercept form. All right, so we have a new example here. Notice this is not in slope-intercept form. So the first thing I'm going to want to do is get this in slope-intercept form. Remember, that means that we just solve for y. We want to get y completely by itself. So the first thing I would do is I would move the -6x over. So now I'm going to have -3y is greater than or equal to 6x plus 12, okay? And from here, that -3 is still multiplying the y, so I'm going to divide each side by -3. So now I'm going to have y, and this is where you have to be careful. Remember, whenever you multiply or divide by a negative number with inequalities, you have to flip the inequality symbol. So this is actually now going to become less than or equal to. So be aware that you're going to have to do that if you ever multiply or divide by a negative number with inequalities. So I now have y is less than or equal to, the inequality symbol flipped, is less than or equal to -2x minus 4. Okay, so there is my line, or that's my inequality in slope-intercept form. Y is completely by itself. So now I can go ahead and figure out my slope is. My slope is -2, and my y-intercept is -4. So I'm going to plot that y-intercept of 0, -4. And now the slope is -2, which means I'm going down to right 1, down to right 1. So down to right 1, down to right 1, down to right 1. And I can kind of do the opposite, going in the opposite direction here. And you can do this kind of until you run out of room. All right, and now we're going to go ahead and connect this with a solid line, because this is or equal to. So I'm going to connect this with a solid line, and there we go. Let me kind of do that. Yeah, there we go. All right, and now we got to think about the shading. Well, once again, you can think about it in terms of, hey, is this less than or greater than? And in this problem is less than or equal to, which means I shade below. Less than, below, greater than, above. So below the line is going to be in here. But once again, say that is difficult for you. Pick any point not on the line, plug it in, and see if it works, okay? So you can plug in 0, 0, you can plug in -8, 0, you can plug in -10, -10 if you want, you can plug in 10, 10 if you want. If it works, whatever that point is, if it works, shade in that region where the point is. If it doesn't work, shade in the region where that point is not, okay? And that's graphing linear inequalities, okay? It's really not that much different than graphing linear equations. So if you know how to graph linear equations, this should be just an extra step or two, okay? So I hope this video helped you. If you have any questions, please feel free to let me know, okay? And in the next couple of videos, we're going to start talking about systems of equations and inequalities, okay? So I look forward to seeing you in the next video.